Assalamualaikum and hi. My name is AIMAN EFFENDY. Today me and my team will present about soil moisture sensor. So, what is soil moisture sensor? A soil moisture sensor is one of the low-cost electronic sensors that is used to detect the moisture in soil. This sensor consists in two parts. One is sensor module and another one is sensing probes. The probes will allow the currents pass through the soil and then it gets the resistance value according to moisture value in soil. The sensor module reads data from the sensor probes and process the data and convert into a digital and analog output. So, the soil moisture sensor can provide both type of output digital and output analog. The sensing probes consist in two nickel-coated copper tracks. Also, it has two header pins. These are internally connected to the copper track of the sensing probes. These pins are used to connect the sensing probes to sensor module through two jumper wires. Always, one pin of the sensor module provides a 5-volt current to the one probes, and another pin of the sensor module has received the return current from the another probe. Normally, under dry soil condition, it provides high resistance and less conductivity. So, the 5-volt current cannot be passed from one probe to another probe. Its resistance will vary according to the amount of water in the soil. When more water in the soil, its resistance will decrease and conductivity will increase. So, when water increases in the soil, it can pass more current from one probe to another probe. This is example of soil moisture sensor. The first one is the capacitive type, and the second one is TDR. It stands for time domain reflectometry, and the last one is rainbird soil moisture sensor. Okay, for technical specification, the specification of the soil moisture sensor is, the first one is output voltage we use for 5 volt. The output voltage we use for 4.2 volt. The input current we use 3.5 milliamp. The output signal both analog and digital. So, for pin out, the soil moisture sensor has 4 types of pins. The first one is VCC, it stands for power. AO, it stands for analog output. DO, it stands for digital output. And lastly, GND, it stands for ground. And that's all from me. Thank you.
Okay, my name is AMIRUL ZULKIFLEE. I will talk about application and measurement produced. Firstly, my first point is theoretical basics. Theoretical basic is the modern physics beliefs that all non-metals and metals under specific conditions belong to the dielectric. By according above formula, frequency is one of the main factors that affect the dielectric properties of soils. By selecting the appropriate electromagnetic frequency play a key role in the measurement of soil moisture by using the electric constants. It can be seen that the moisture content of soil and can directly affect its electric constants. Therefore, the soil moisture contents can be measured by measuring the electric constant of the soils. Okay, my second point is how the working principle of the sensor. Principle of the sensor are 3 points. Firstly, the radio wave generated by the signal source was terminated to the probe using a transmission line. By additional that, the impedance of the transmission line was not matching with the impedance of the probe. Some of the signal were reflected back in the transmission process to form a standing wave with the incidence wave. This because the amplitude of each point voltage on the transmission line to change the dielectric constant of soil determines the probe impedance. So, the change of voltage on the transmission line directly reflects the change of moisture in the soils. Okay. Next, the transmission line used in this article was a coaxial cable, which was considered as a lossless transmission line. But according to the theory of transmission line, the peak voltage of A and B can be obtained when the length of the transmission line is equal to 1/4 of the wavelength. The peak and trough of the standing wave are exactly at both ends of the coaxial cable, where the value of A depends on the amplitude of the oscillator, and ZL is the impedance of the probe, which is related to the dielectric constant of the source. However, ZC is the characteristics impedance of the transmission line, and P is the reflection coefficient of the transmission line at point A. Therefore, we can indirectly obtain soil moisture content by measuring the voltage difference at both ends of the transmission line. Okay, my last point is the structure of the sensor. According to the working principle of the sensor, combined with its actual measurement requirements, the design of the structure of the soil moisture sensor. The probe electrode, composed of a printed circuit board, has two pin type pedal structure and was electrically connected to the electronic circuit equipped with sensor and was highly integrated to form an integrated structure. By addition that, the probe ends were designed to be triangular in order to be easily inserted into the soil to be tested. After filling, the electronic circuit area was sealed with a rubber shell. Only a sealed 3-core wire was used as the external interface. Lastly, the 3-core lines were repetitively connected to the power input of the sensor, the ground wire, and the signal output line.
Okay, the next one will be the testing procedure. Testing procedure will be that the goal of this instructable is to see if it has rain and if the plants are receiving water. If the soil is wet, the red LED will light up, and if the soil is dry, the green LED will light up. First of all, we will gather all the things. First one will be the jumper wire, soil moisture sensor, yellow LED, blue LED, breadboard, Arduino Uno microconnector, wet and dry soil in beaker. Step 2 will be to connect the wires and moisture sensor to the Arduino board as specified in the diagram. Once the circuit is built, upload the code in the attached document to the Arduino. Once upload, open the serial monitor window to see if the setup is working. See a value at or close to 0 when the sensor is not touching anything. To see its sensor moisture, you can grab both probes with your hand. The moisture from your body will be enough for the sensor to detect. Step 3 will be confirming that the serial monitor is detecting the right values. must attach the rest of the wires and the LEDs as the pictures clearly shown above. Step 4 will be the final code. Attach the code in the new Arduino. Now the entire setup is complete. Open up the serial monitor window once again. Take the dry soil and place the soil moisture sensor into the soil. If the blue LED lights up and the serial monitor says value less than 600, the setup has worked. On the other hand, for the wet soil, the serial monitor should have values above 600 and the yellow LED should be light up. If both of this situation happens, then the soil moisture sensor is working correctly.
For the conclusion, we know that soil moisture sensor can give many benefits to the users. This paper mainly discusses a new type of soil moisture sensor with high performance and no damage. The calibration test and analysis showed that the output voltage should have a linear negative correlation with the volumetric moisture content and the convention of determination. It can be known from the accuracy measurement experiment that the average absolute value of errors is less than 2.5%. The results show that the sensor has stable and reliable performance, high accuracy and good linearity, and can meet the requirement of practical application, and it is suitable for water measurement of most type of soil. That's all. Thank you.